All right, now we're starting lesson 10. We're going to be talking about square roots and radical signs. So in 10-1, we're talking about square root functions, dilations of radical functions. It's basically when you take a parent function, just like we did with quadratics, right? We had y equals or f of x equals x squared. That was like the most basic kind of graph, right? And we knew that was a parabola that went through the origin. This is the same kind of thing. It has a parent function, okay? So I'm going to explain all the pieces of this, but dilations of that are whenever we put numbers in front of or behind to see how the graph changes, right? To see how the graph shifts. So that's a dilation. All right, so when we think about radicals, first of all, a radical sign is like the square root sign. Okay, so this is a radical sign, this little check mark thing. Looks like a cross between a check mark or what am I trying to say? A division sign, right? So that's the radical. And then whatever's underneath the radical, the entire thing, the value of everything under the radical, we call that the Raticand. So if you see the word Raticand, it's just talking about whatever's under this radical sign. Okay, so the gist of it is that whatever's underneath this radical sign cannot be negative. Okay, a radical sign means square root, right? Now there's other radical signs. If we put a little 3 right here, then this would mean the cube root. It means what number did I multiply by itself 3 times to get this, right? For square root, it means what number did I multiply by itself 2 times. So if I took the square root of 9, right? What number did I multiply by itself 2 times to get 9? 3 times 3, right? I multiplied 3 times 3 and I got 9. What about 16? What did I multiply by itself? 4. What about 25? What did I multiply by itself? 5. So it's kind of going backwards from squaring something, right? 3 squared equals 9, and then the square root of 9 equals 3, right? We're just going forwards and backwards. 4 squared equals 16, and then the square root of 16 is 4. 5 squared equals 25, and then the square root of 25 equals 5. And it actually, whenever we take the square root, it can be positive or negative, right? This is plus or minus 3. 3 times 3 is 9. Negative 3 times negative 3 is positive 9. 4 times 4 is 9. Negative 4 times negative 4, 4 times 4 is 16. Negative 4 times negative 4 is 16. 5 times 5 is 25. Negative 5 times negative 5 is 25. So we put this little plus or minus symbol because it means whatever number's after it. Like let's say we did 6, right? Positive 6 or negative 6. 6 times 6 is 36. Negative 6 times negative 6 is 36. The square root of 36 is going to be positive or negative 6. That's all that means. Okay, so think about it this way. Whenever you multiply something by itself, the answer is always positive, right? Because if it's the exact same number that you're just multiplying by itself, if they're both positive, a positive times a positive is positive. If they're both negative, a negative times a negative is a positive, right? So the number underneath the radical sign, the Raticand, always has to be positive, always. So that's the main part of our lesson here. So in order for the square root to be a real number, the Raticand, or the number under the radical sign, cannot be negative. Has to be positive. Just not possible to be negative. You can't take the square root of a negative number. All right, so here's our parent function. Let me highlight that. So, and remember, f of x is just function notation for y. It's the same thing as saying y equals the square root of x. So basically, we're going to start filling out charts to graph these functions. This is a radical or a square root function because the variable is underneath the square root sign. So it's not just x, and it's not x squared, it's the square root of x. Okay, so that's the parent function of that when we graph it is gonna look like that. All right, to graph it, there's no fancy tricks. We're just gonna fill out a table and plot the points that we come up with. Okay, so type of graph, it's always a curvy graph when it's a radical sign. Domain and range. Well, domain is all the possible x values, and since a negative number cannot go under the radical sign, we cannot have negative numbers in our x for our x values. So we can only use 0 and up. So our domain is whenever x is greater than or equal to 0. It cannot be negative because we can't have a negative number here. okay? And then whenever, since x is positive, no matter how tiny that number gets when we take the square root, it's never going to be negative. So when x is always positive, y is always going to be positive. Now, we might do things to that, like we might add a number onto the end after this radical, not under the radical, but after the radical sign. That would change our graph. We might put a number in front of the radical sign. That's going to change our graph. But as far as the parent function, just square root of x, this is what it looks like, okay? So here, they give an example. We're going to do 3 here at the bottom in a second, but they want us to graph y equals 3 times the square root of x. This is a square root function because x is under the square root sign. So state the domain and the range after we graph it. So first thing they do, step 1, is to create a table. You can put in whatever numbers you want for x, but remember, they can't be negative. So you're kind of usually going to start with 0, and you're going to go up. And how you go up just depends on how big your graph is or what numbers you want to use, or usually it gives you a little guidance, right? But it does, you can just go 1, 2, 3, 4, 5, 6. That's fine. I don't really know why they use 0.5 here, but that's okay. All right, and then once we plug this in here, they got y values. So how did they get that? Well, when they plug in x, we got y equals 3 times the square root of 0. The square root of 0 is 0, and 0 times 3 is 0. So here, y equals 0. That's how they got a 0 here. When x equals 0.5, y equals 3 times the square root of 0.5. You got to have a calculator handy. So if I put 0.5 in my calculator and hit square root, I get that long guy, and then I multiply him by 3, and I get 2.12-ish when I round. So they got 2.12. Okay, when I put 1 in, oh, but y equals 2.12. When I put 1 under the radical, y equals 3 times the square root of 1. 1 is a perfect square because 1 times 1 equals 1. So if I hit 1 and then hit the square root sign, I get 1. And then I multiply it by 3, so y is 3. And that's what they got here. Okay, so that's what they're doing. That's how they got all these values. So once we have these values, these are all ordered pairs, right? This top guy is 0, 0. The next guy is 0.5, 2.12. They're all just ordered pairs. So then we're going to graph. We're going to plot each of those points on a coordinate plane. So we've got 0, 0. Then we go over half a unit up 2.12, so just over 2. We go over 1 unit, up 3 units. We go over 4 units. Oh, we went over 2 units, sorry. When we go over 2 units, we get about 2.24. I'm just looking at this right here. This file is included, so you can always print it out and look at it yourself. When x is 2, y is 4.24. When x is 4, y is 6. When x is 6, y is 7.35. So they just plotted all of these. Right, so this is the graph. Now it looks a little different from this parent graph, right? It's a little taller. It goes up a little further, but none of the x values are negative. None of them start over here. And none of our graph goes below the x-axis. So none of our y values are negative. None of our x values are negative. None of our y values are negative. So our range and domain are the exact same. The domain is x has to be greater than or equal to 0. The range, y has to be greater than or equal to 0. Remember, domain is what possible values can I put in for x in this equation? What are all the possible values? What's the range of x's I can put in this equation? A lot of times it's going to be infinite, right? You can put any number in you want for x. But in a square root function, all your numbers for x have to be bigger than 0. They have to be positive numbers, or they can be 0. So let's do 3 problems down here. We have to graph each one and tell the domain and the range. So here's this guy right here. I went ahead and kind of wrote out a little graph. Okay, so x is going to start as 0. Can't be less than 0, so we start at 0. When we plug a 0 in here, square root of 0 is 0. And anything times 0 is 0, so y is going to be 0. And then I can plot that, 0, 0. When x is 1, the square root of 1 is 1. 1 times 3 halves is 3 halves, and 3 halves is the same thing as 1.5. So I'm going to go over 1, up 1.5, so right about here. When x is 2, what's y going to be? Well, I got to find the square root of 2. 2 square root. And then I'm going to multiply that by 3 halves, which is 1.5. And I get about 2.12. 2.12. When x is 4, what's y going to be? Well, the square root of 4 is 2. Multiply that by 1.5, and I get 3. Okay, so when x is 2, I didn't plot that one. I'm going to go over 2 and up 2.12, just over that 2. And then I'm going to go over 4. I skipped 3 here just because I knew 4 was a perfect square, and I didn't want to just go 1 through 6 or whatever. So I'm not going to go over 3. This is 4, so I got to go over 4 and up 3. So right here. When x is 6, what's y going to be? Well, square root of 6. Hopefully you guys can see this okay. Times 1.5 equals about 3.7. So I'm going to go over 6. 1, 2, 3, 4, 5, 6, and up 3.7. 3, it's like 3 3/4 almost right here. Okay, then the next one I have is 8. So when x is 8, what's y? The square root of 8 is that. Multiply it by 1.5. And I get about 4.24, so about 4 1/4. So I go over, oh, what did I say here? 3.7, I think. And I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 4.24. 1, 2, 3, 4 1/4, about right here. And then last but not least, and actually it goes a little bit off our graph, but I went to 9 because that's a perfect square. The square root of 9 is 3. 3 times 1.5. Remember, 3/2 is 1.5. So square root of 9 times 1.5 equals 4.5. So I'm going to go over one more line here on my graph. And I'm going to go up about 4.5. So here's 4.5 is right about here. Okay, so my graph looks kind of something like this. It's not perfect, but something like that. So my domain and my range are still x has to be bigger than 0, y has to be bigger than 0. So domain, x can be 0 or it can be bigger than 0. Range, y can be 0 or it can be bigger than 0. Okay, next one. We're going to do the exact same thing 3 times. I'm trying to give you lots of examples to help you guys do your own assignment. All right, so now we have y equals 4 times the square root of x. So when x is 0, 0 times 4 is 0. When x is 1, the square root of 1 is 1 times 4 is 4. When x is 2, the square root of 2 is that long decimal times 4 equals about 5.7-ish, 5.66. We're going to say 5.7. I'm going to start plotting these. So I got 0, 0, over 1, up 4. Well, that's big. Over 2, up 5, almost to 6, 5.7. Okay, when x is 4, so I skipped 3. I'm not going to plot anything on this line, but I am on this line. When x is 4, square root of 4 is 2. 2 times 4 is 8. So I'm going to go over 4, up 3, 4, 5, 6, 7, 8, right there. And it looks like I'm going to run out of graph. I'm going to keep filling out my table, but it looks like I'm going to run out of space here. Okay, so when x is 6, the square root of 6 is that times 4 equals about 9.8. And my graph only goes up to 8, so I can kind of eyeball it. So I'm going to go over 3, 4, 5, 6, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, about 9, and almost up one more is about 10. Okay, now since my graph keeps going up, but I mean my actual graph isn't any bigger, but my numbers keep going up, it's probably not smart for me to keep using bigger numbers because I ran out of room. What could I use? Well, I didn't have a dot here at 3, so I could go back and put in 3 for x, right? The square root of 3 times 4 is about 6.9. So I can go over 3, up 6, almost to 7. I could do in between too, right? I could do 0.5, 0.5. So when I take the square root of 0.5 and then multiply by 4, I get about 2.82. 2.82. So if I go over a half, I'm going to go up 2, almost to 3. Right? Kind of making sense. So they should fall in this like curvy kind of line. So that's what I mean about picking numbers to go in for x. You got to kind of see what makes sense. For this other graph, I went way up with my numbers, and that's okay because my graph was pretty flat. For this one, I didn't need to go way up with my numbers because the bigger x gets, my graph starts going way off the page, right? So I can use smaller numbers. So now I'm going to kind of sketch this. And then my domain and my range are the exact same thing. X has to be bigger than 0 or equal to 0. The range y has to be greater than or equal to 0. So d, x greater than or equal to 0. R, x greater than or equal to 0. Okay, and one more, last one. Oh, we got another pesky fraction here. Before I even start solving this, I'm going to figure out what the decimal version of that fraction is. 5 over 2 is 2.5. So really, my equation is 2.5 times the square root of x. That's what I'm calculating for y over here. Okay, so when I plug in a 0 for x, this becomes 0. 0 times anything is 0. So I go ahead and plot that. Okay, when I plug in a 1 for x, square root of 1 is 1. 1 times 2.5 is 2.5. So I'm going to go over 1 up about 2.5. Okay, then when x is 2, what's the square root of 2? Times 2.5 is about 3.5, a little bit over. So I'm going to go over 2 up 3.5, a little bit bigger than that. When x is 4, well, square root of 4 is 2. 2 times 2.5 is 5. So I'm going to go over 4 up 1, 2, 3, 4, 5. Notice I didn't do 3. You know it's not here, but don't forget that you're not graphing that next line. Okay, when x is 6, the square root of 6 times 2.5 gives us about 6.12. So I'm going to go over 6, 4, 5, 6, 6.12, just over 6. And let's just do, let's just do 9. It's a little bit off the graph here. Imagine there's like one more line drawn here. And square root, I'm just going to skip this one for now. Square root of 9 is 3. And 3 times 2.5 is 7.5. So when x is 9, x is 9, y is 7.5. So I'm going to go over 9, up 6, 7.5, about right there. So my graph looks something like that. Okay, so that's my graph. There's my table. My domain and range, again, are the exact same thing. X has to be greater than or equal to 0. Y has to be greater than or equal to 0 because none of our graph goes below here or left of here. So domain, x greater than or equal to 0. Range, y greater than or equal to 0. Hopefully that's making sense. Stay tuned for video 2 and let me know if you have questions like always.